Dear listeners, welcome to Entrepreneurship of Life, a series of dialogues with distinguished immigrants in Silicon Valley, plus AI insights. I am your host, Sophie Wan. I advise early stage startups and founders, especially those building with AI. This is our inaugural episode, and with two awesome guests, we'll chat about a common challenge for AI builders today. That is, understanding how transformer models work, evaluating them, and getting the best performance at the lowest cost with something called model routers. We'll also discuss the AI ecosystem more broadly, put it in historical context, and imagine its future. Now, this is a somewhat technical episode. If you're less familiar with large language models or LLMs, don't worry. We'll do our best to break things down and keep them digestible for everyone. First things first, introductions. Our two guests today are both experts in AI and data with experience across North America and Asia. Our first guest, Yuzhong Sun, is a data scientist at Statsig, the leading feature management and experimentation platform. Backed by Sequoia, Statsig serves many clients, including OpenAI and Character.ai. Previously, Yuzhong had various DS and economist roles at Tencent, Meta, and Amazon after his econ PhD from Cornell. Yuzhong is also a prolific blogger on tech, data science, career, and personal growth, with 0.2 million followers across platforms. For our Chinese listeners, you can find him online as 课代表李正. Yuzhong recently interviewed Mike Vernal, ex-partner at Sequoia, early investor in Rippling and Notion, and ex-Meta VP. They talked about the secrets of Facebook's early exponential growth, which is a great lesson. You can find the link in the show notes. Our second guest, Jason Hu, is the founding engineer and employee number 2 at Martian, a fast-growing AI startup. Their first product launched last year, an LLM router, is already adopted by developers from 300 plus companies, including OpenAI and Amazon. Jason is responsible for the core algorithm behind this router, and he writes papers on this frontier technology with Professor Kurt Kutzer from UC Berkeley. Before Martian, Jason did research at the Chicago Human AI Lab in ByteDance and graduated from UChicago. He currently leads one of the biggest AI communities in the Bay Area, Alliance.ai, with event speakers and community members from OpenAI, NVIDIA, Stanford, and so on. If you're in the region, definitely check out their events. Again, link in the show notes. Now, without further ado, let's dive into today's topic: LLM interpretability, evaluation, and routing.
As we know, AI models based on deep learning and neural networks are notorious for being black boxes, in the sense that it's hard to understand exactly how they arrive at a particular decision or prediction. This became increasingly concerning when state-of-the-art transformer models like GPT acquired emergent capabilities such as reasoning. As we approach a future with artificial general intelligence, or AGI, if we cannot even interpret model behaviors, it draws into question whether we could really guarantee the models are working in humans' best interest. So this is why major AI labs, including OpenAI, Anthropic, Google, and so on, all view model interpretability as crucial and are working actively on it. Jason's company, Martian, shares this goal. In fact, that is how you guys chose this name, Martian, to begin with. So, Jason, why don't we start there? Why the name Martian, and how does that tie to your goal of making models interpretable?
Thanks so much for the intro, Sophie. It's a great pleasure to be on the show. Martian, the name actually comes from a group of Hungarian-American scientists known as the Martians. So this group is like a bunch of very luminary mathematicians, computer scientists, physicists in 20th century. So the Martians include John von Neumann and Paul Erdős, which is a very prolific mathematician, Leo Szilard, who is the father of the atomic bomb. And very interestingly, all those people, they were born and raised in a small community in Hungary. When at the beginning of a company, the founders were very furious about this phenomenon. Why is so much intelligence aggregated in such small circle of people? And this strongly tied to our main research and business interests, which is making intelligence understandable. How do we better interpret, understand, and utilize this intelligence? So that's the origin of the name Martian. So I can tell you guys more about what Martian is doing. So we are basically the first product. It's building an LLM router, which is basically a middle layer that allows users to intelligently use and select multiple LLMs at the same time. Love to dig more into it later.
That's fantastic. We'll get into that in just a second. And Jason, I love how you tied interpreting models with ultimately utilizing or accessing the power of intelligence or artificial intelligence in the way that we're comfortable with. Model interpretability, it's a general term. It has many elements and layers. So my next question is for both of you. What does model interpretability mean to you? And specifically, what do we need to understand the most about how transformers work? Let's start with you, John.
Okay, two questions, right? The first is, what does model interpretability mean to me? So my training was in economics, and in economics we were obsessed with model interpretability because we are obsessed with causal impact, and we also want to understand the cause and consequences. That's why we usually go to the most simple model, like when we use linear regressions when we can instead of machine learning. My general intuition is deep learning. If you go to deep learning, you lose all the interpretability, and the transformer is no exception. I don't think there is. It is more opaque than other deep learning models because in the grand scheme of things, they are just not interpretable by human. Like you can get pieces of information here and there, but we just do not understand how it works. The ChatGPT is like the emergence ability. You mentioned that earlier, right? The reasoning is emerged, and that is even more puzzling, which actually prompts me to thinking about humans. Like, do we understand why we are conscious and how our brain works? And I realize we know little about why humans have intelligence. So nowadays, I guess I take a more pragmatic approach. For example, this is the first time we talk, right? I won't assume that I know why you think about certain things, like how your mind works. I won't even assume, are you actually human or an alien or a large language model? But we have this exchange of information, and I can assess whether this exchange is informative based just on the results of our intelligence, or just the words, or just the language. I don't need to worry about interpretability like we worry about model interpretability. And to keep it short for the second question, I hope someday we can understand how transformer work, and why it can produce certain information, and hopefully it can shed more light on how our brain works, how intelligence and consciousness works. I won't hope for that. Like I don't expect that to happen, but yeah, that would be the ultimate goal.
It does seem that the more we understand about how machines reason and think, the more we are also learning about human intelligence. So,
the more we realize how little we know about human. Martin, that published the 20 biggest question or the biggest unknown for human in the 21st century. Why we dream, what is consciousness, or just why we are fundamentally different from monkeys are unknown questions to human.
That's fascinating. How about we also include a link to this read in the show notes? Thank you. And Jason, what about you? What does model interpretability mean to you, and what elements does it involve?
I also study economics at U Chicago, so I can totally relate when Yuzheng mentions the model interpretability in economics. There's always a tension between interpretability of the model and the power of the model, right? So for example, we can also build an extremely complex model with trillions of parameters to perfectly predict or like describe some sort of economic phenomena. But this very complex model does not tell us anything about the fundamental mechanism of the market. I think what really impresses me when I learn economics in school is that many of the models, they're actually very simple, right? It's like human optimizing their utility, and it's like very simple one-line equation. And deriving from the simple mechanism, we can have explain or even predict many complex economic phenomena. I think this dynamic between interpretability and power of the model sort of favors power of the model in the current AI space. I'm sure many audience know about the bitter lesson, which is an argument saying that, the biggest drive for AI development is an increase in the computational power and the amount of data. And basically, in Chinese, called 大力珠机器, right? We don't care about whether the model is interpretable. We just throw more and more compute and more data, and magic will happen. And this is exactly what we are seeing in the current wave of large language model. Like Ilya Sutskever even said that, why deep learning work is like a miracle. Right? It's like beyond human interpretation. Before ChatGPT, everything is open. Because before that, AGI is like a distant dream, right? We cannot really imagine a model that is better than human in a general way. But after ChatGPT, we see that this can create huge issue. We can actually have models that are much more powerful, much more knowledgeable. They're able to do anything with this increased compute and data. And that's why we need to basically, in the dichotomy between interpretability and power of the model, we need to shift back and to focus more on the interpretability. We need to understand more how does LLM models work, and thus we can better control them, right? To make sure all those super intelligence entities don't just randomly like destroy humanity or something. So I think that's like a very important part of aligning AI and making sure that they're safe. So what do we need to understand about how transformers work? We understand perfectly well the mathematical formulation of our transformer at the very bottom level, right? We also understand fairly well about their top level performance. They can act like a human, they can talk like a human, but I think there's like a missing middle layer. Like how do we connect the top level intelligence directly back to the individual neurons, individual computations that's performing within neural network? So one academic field that's dedicated to connecting the top level to the bottom level is called mechanistic interpretability. So basically, many researchers at MIT, at Anthropic, they have developed methods to say that I can identify some neurons. This neuron is used to identify certain words. This neuron is used to perform like causal reasoning or stuff like that. So that's like very great early work in the field. At Martian, we're aiming for something more systematic and bigger. So we want to not only explain individual neurons, we want to understand the whole transform as a system. We want to turn them into code, into computer programs, so instantly like interpretable as a whole.
Thank you for breaking apart for us why we should try to understand model interpretability as opposed to simply pursuing bigger and stronger and all that. And also, like, what specifically does model interpretability mean at a kind of more concrete level? Now, given how little we know about what happens inside those large models, it makes assessing their individual strengths and weaknesses harder. And to your point earlier, Jason, that is a part of making alignment between AI and human trickier. So that's a real problem because millions of developers building on top of large models today have too many models to choose from. The number of models hosted on Hugging Face right now is pushing 500,000. That was a jaw-dropping number for me. And over just the past year, that count has almost 5x. There's only a handful of these models that are considered frontier or top in overall performance. But even those models aren't always the right choice for an application builder when costs and latency are taken into account. So choosing the right foundational model has become a headache for so many AI developers, but this is also an issue that nobody can afford to ignore. The foundational model directly affects how well the application on top works and whether it is economically viable. To many AI native startups, this could literally be a matter of life or death for the business. Now, Yujun, you talk to a lot of AI builders in your work and for the content you created. So from your observations, how do the AI builders today approach choosing the foundational model or models for their application, and whether there is a difference in approach between those at large enterprises versus AI native startups?
Good question. And it's a very complex question because I think the big players, they're not only trying to choose the best model, they also want to be the provider, right? They all want to be the builder of the models. So it's not necessarily choosing the one with the least cost and the best performance. It's about how to do this strategically. Last week, I received an email to tell me to renew my domain, and the domain name is LLMevaluation.com. So if you go to LLMevaluation.com, it goes to my YouTube channel. I bought this over a year ago because over a year ago, I feel like this is going to be an important issue, and turn out it is. So glad that many companies are trying to solve this. And if you're interested, let me know.
By the way, quick addition there. You were definitely very early in thinking about this because the search term LLM evaluation actually went up 30 times from January last year to this past January. So
nice.
You're ahead of the game. Anyone interested, please reach out.
Yeah.
Sorry, please go ahead.
Yeah. Great. Thank you for the plug-in. Yeah. I think the problem is more complicated than most people can think of, because traditional ML, the evaluation is relatively simple. Right? You have the performance of the model is defined on the last function. Can you optimize that? And that comes down to a single number. And then you have the gap between model performance to the production performance. And then you introduce user behavior, such as if your model is good, can you actually increase click-through rate? That is still relatively simple, and you can do A/B testing to get a result. But for LLM evaluation, it is almost like evaluating a human. And you cannot judge the foundation model just based on some simple outputs. That is the challenge. And I'm glad that Martian is addressing this issue. If Martian solves this problem or builds a very good router, then we should just trust the router, right? Because the router tries to optimize the evaluation of model performance given a certain business goal. So even though we cannot solve this question fundamentally, I think pragmatically there is a solution. And because the business goal can be defined and the cost can be defined. So that is one dimension. How to evaluate the best performance is hard, but it's solvable. There is another layer that is all the big tech companies or the small companies. They try to be in the game, right? My personal view is we are at the kind of the exponential growth stage of the S curve, and you are not anchoring on the current state of OpenAI. OpenAI also is developing and also is growing, and is probably growing faster than most companies are. So you are actually fixating on a dynamic target that is becoming harder and harder to catch up with. Sora, I think, gives us a good preview of this challenge. So my personal view is do not worry about this problem too much. Just use OpenAI, just use ChatGPT, and when GPT-5 releases, then everyone realize, okay, I should just build my ecosystem on top of ChatGPT all along. So yeah, that is my personal biased opinion, but I do recognize it's a very hard and complex challenge.
Hey, we love unfiltered opinions on this. There's consensus that GPT-4 and maybe a couple of the other models are really leading in terms of the ability of reasoning and the ability to like accomplish tasks, follow instructions, etc. The situation gets a little murky when we look at inference costs and like latency. Even less technical people playing with GPT have probably experienced that GPT-4 was better, but much slower than the previous generations. The question becomes a trade-off between performance on one hand and cost and latency on the other. But while we're still on the topic of evaluating performance, I want to follow up on that real quick. So how is the evaluation conducted typically? And as we know, there are both human involvement or human component in there and also automation and, sometimes even AI evaluating AIs. So how does automation and human involvement each play a part in model evaluation today?
Honestly, it's quite tricky, as Eugen also mentioned. I think we can draw an analogy on evaluating LLMs as to evaluating humans, right? So depending on what kind of work that human does, the way we evaluate that is quite different. So for some of the very basic tasks, right? So let's say, someone with a factory producing some simple goods, we can, automatically use, for example, the size or the weight the good produced to evaluate output in a very systematic, automatic way. On the other hand, when the tasks become more and more complex, like what we see in the tech companies, like code review or like performance review, it can be very subtle, involve even politics involved. It's similar for evaluating LLMs. So, for example, some of the simplest, most straightforward and widely adopted evaluation set out there is called MMLU. It's basically like multiple choice questions. Like the model just output A, B, C, D. That's it. And they have, multiple choice questions, in the tens of thousands and covers so many different subjects. So it's a very comprehensive, very fast and easy way to evaluate the model's reasoning ability and knowledge in all those fields. And we have something that's slightly more complex. For example, we can try to evaluate the model's ability to do mathematical reasoning, mathematical calculations. So we can tell the model to output a number, and we can basically analyze a number, whether it's like the correct, or a bit more complex, we can let the model to output a code. So we can then execute the code to see if the output is what we expect. But there's many tasks, like in production, we see many clients, they want to let the model to summarize an article to produce some sort of writing. It's more tricky to evaluate. We don't have enough human labor to evaluate them. So one widely adopted technique is called using LLM as a judge. So let's say we want to compare GPT-3.5 versus Llama 7B. So we give the two results to GPT-4 and to tell GPT-4 that here are the things that they need to satisfy that, for example, if a summary, it needs to be concise, it needs to cover the most important points in the article, and blah, blah, blah. And given those criteria, which of the output you think is better? So with many of the statistical techniques, we can make sure that the LLM judge output is robust, is statistically significant, we can eliminate noise, and it can actually achieve pretty good results. And finally, of course, we can collaborate with data labeling service providers like Scale AI or just label data in-house. Yeah, it's quite nuanced and complex. There's a whole array of different methods we can use to evaluate LLMs in production.
Awesome, Jason. Thanks for laying the land for us in terms of the major approaches to evaluating models. And of course, if that were easy, everybody would be doing it perfectly already, and you guys would be founding something else, right? So that is not the reality we live in. So in production, what are some of the common challenges that AI developers often encounter in evaluating, which model fits their need the best? And this is a question for both of you. And Eugen, what do you think?
Because all the large language models are beta or preview of the kind of what we try to do, right? They are the first generation production models. I don't think we have a mature ecosystem. So the common challenges are similar to other industries who are too early. is developing so fast, right? So today's solution becomes tomorrow's abandoned solution. So I guess that is the common challenge. It's not stable, and also just the industry is not ready. I feel like if you want to use large language model well, you need your data to be ready, so you can do good retrieval and get the correct amount of knowledge. But that also goes to the development part, right? Like I remember vector database used to be a hot topic, and then people talk about RAG, and now we hear people sharing, the long context window is going to be the solution. We don't even need RAG. So just in order to unleash the full potential of the existing model, there is a long way to go, and the models are developing very fast. So I feel like we are going to see this catching up with the new technology for quite a while before we actually have this in production that is mature, ready, and sustainable.
Jason, I know you guys are working with a lot of developers who are having a tough time choosing between models. So what are you seeing in terms of their pain points? And I know you guys work with both large enterprises and also like startups, AI native startups. Are there any like patterns or maybe differences that you guys are seeing?
I totally agree with what Yuzhen had just mentioned, that the industry is just developing so fast and is actually imposing a lot of challenges to many of the AI developers out there. For example, right now, one of the best open source models is like Mixtral 8x7b, and like many developers just don't know that it can achieve in many scenarios performance as good as GPT-3.5 Turbo at half or even a third of the cost. But it's like a new model. The company is not as famous as OpenAI or Anthropic. They just simply don't know, right? And also models like this are popping up every single day, and it's impossible for developers to just catch up on all of the latest developments and keep their AI pipeline updated. So that's a major challenge. And a bit more nuanced and further challenge is that different models are there is subtle detailed difference in their reasoning capability and knowledge. For example, one thing we tested last year is that we found that Anthropic models like Anthropic Claude Instant is actually better than GPT-4 as some foreign language understanding tasks. So it's possible that Anthropic, they just train more of those relevant texts, and the GPT-4 is like not that familiar with that. So it's actually very subtle difference, not on the general level, but on a task specific level. That like the different models have different strengths and weaknesses, and it's pretty tricky for developers to get to know all those details and choose the best model for their specific task.
I want to, Jason just reminds me now, our old way of developing was built upon accurate results. So you need a certain format of a function. If you have one space in between, the whole result just get messed up. But large language models are not designed to provide accurate results, but they can also understand fuzzy inputs. So right now we are in this transition period. All the infrastructure, all the old capabilities are built upon accurate input and output. But we have a new way of producing fuzzy output and understanding fuzzy input. I think the transition is going to take a while. But during this transition, we are going to face a lot of challenges. But I think the direction is once we have a whole set of infrastructure or AI native, when I say AI native, I mean the function can take fuzzy input and can produce fuzzy output, then we'll unlock a lot of new scenarios and capabilities.
Appreciate the sharing from you both. We're in the early innings of probably a very long journey of making models more steerable, more reliable, and more aligned. And I know we've talked a lot about the challenges, but don't worry, we're switching to talk about solutions now. Jason and his team at Martian have built an LLM router to take over the big thorny task of evaluating and choosing the right large language models on behalf of your clients. So, Jason, LLM model routers are a relatively new concept. So, in the simplest terms, could you maybe just overview for us what is a model router and what does it do?
On the high level, what a router is that given the prompt, we route the prompt to the best LLM to optimize for cost, performance, and latency, and other metrics you care about. There's one big difference that people always confuse us with some other quote unquote router companies like Open Router, where they're building something called Gateway. So a gateway is basically a unified API that allows you to call different LLMs in one endpoint, right? You can use Open Router to call GPT-4 or Anthropic Claude or any other models. Martian, we have our own gateway, but we are building on top of that. So we are building what we call like dynamic router. So it's not like, okay, so for this API, I will just always use GPT-4 or I will always use GPT-3.5. So when the user calls our API endpoint, they don't know what LLM we are routed to. So we build an algorithm to intelligently analyze a prompt and based on our understanding to the user's objective, we automatically route each prompt to different LLMs. So for example, let's say the user is building a summarization endpoint. So when the user is summarizing a very simple, very straightforward task, you do not need to route it to GPT-4 because it's quite slow, quite expensive. Very small models like Anthropic, like Claude Instant can do the job pretty well. So we route to smaller models to save cost. And when you input like very complex, very hard math paper or something like that, you actually need GPT-4 level reasoning capability to do the task well. So we can recognize that and route to GPT-4. Basically, on the high level, we build like task-specific routers to help users to achieve better latency, lower cost, and better performance that surpass any individual large language models. So that's what router does.
Thank you. I love the dynamic approach because the optimal model differs not just from one application to another, but also sometimes from one specific task to another. And I think you guys at some point mentioned that for a complicated task that could involve multiple steps, it's possible to route each step in that task to a different model that's best for that, and then kind of like chain the results together. Is that right?
Yeah, exactly.
Pretty cool concept to me. It's just like the Avengers team of superheroes and dynamically calling their different superpowers. So I love that. In a recent paper, you and your co-authors, including Professor Kutik from Berkeley, showed that even simple model routers, like those much simpler than what you guys are using for Martian, can do meaningful improvements against benchmarks than individual LLMs. So can you tell us more about your work there and your findings?
Yes, absolutely. We basically propose a benchmark to evaluate LLM systems, right? So you can see like any large language model, you can put it in a like XY axis. On the x-axis, there's cost. On the y-axis, there's performance. So we always want lower cost and higher performance, which is in the upper left corner of the graph. But in reality, what we usually have is either the model is more expensive and more performant, like GPT-4, or cheaper but less performant, like all the open source or small models. So what we found in the paper is that, first of all, the Oracle router is very, very good. Oracle router can be theoretically achieved by dynamically routing between different LLMs for a simple when we have the perfect knowledge about which LLM is best at what task. And the Oracle is always better than the best LLM and as cheap as the cheapest LLM, right? So there's a lot we can do for routing. We also constructed a few very simple routers using KNN or MLP, all those simple machine learning algorithms. And although in some complex tasks they are not that impressive, but for example, we found that in a RAG case, like retrieval augmented generation dataset, it's actually able to outperform like even the best LLMs out there. So also note that we are only demoing the very simple routing algorithms, and there's like whole like huge design space for how we can construct routers. So I think it's like a very promising field that we have built a benchmark so other people can build new routers and test on our benchmark.
Awesome. Thank you for sharing that. It's exciting to think about how much potential there is from using routers to optimize performance. And so, Jason, let's talk about the router you guys built specifically. So according to your website, the Martian model router beats GPT-4 over 9 out of 10 times against a set of evaluation benchmarks put out by OpenAI. And by beat, I mean performing at least as good, but at a lower cost. And on average, your router saves 20% in cost when optimizing purely for performance. Wow, that is impressive. At a high level, what can you tell us about how Martian picks the best model or models for a given client request, such as what input do you need from the client, and how does Martian then do the optimization? How do you evaluate model performance? So what can you tell us about that?
Yeah, absolutely. Also, some caveat on that. Basically, we use OpenAI evals to produce the numbers we put on the website, and they are more like static valuation sets where we can do a lot of optimizations onto. But in reality, the situation is always more complex. So it's not to say that we can in any use case we can achieve that magical result. But in most cases, we can give our clients a very significant value prop. I can share a little bit on how exactly do we do that. One very important thing to recognize is that we don't do a generalized router. It's like no single large model we apply in any scenario that can magically produce great results. It's more like scenario by scenario, more customized use case. Because each client, they have different cost, performance, latency, compliance, objective functions. And some clients, they really care about performance, right? Some clients, they want performance that's better than GPT-4. So the router we build for them will be very different from some clients who, doesn't really care about performance, but want really low cost and low latency. Right? We need to build a whole pipeline from model selection, sometimes fine tuning, quantization, and stuff like that, to building training a very good model router, and we even modify different prompts. So it's like a holistic engineering effort to optimize every segment in the whole stack. And also, surprisingly high percentage of the time, people don't know what they are optimizing for. Like they don't really have a performance metric. Like Eugen says earlier, like people are still learning how to build LLM systems because it's like fuzzy input, fuzzy output. We don't have a quantitative metric yet. So many times we also need to work with them to develop such metric, like what output is considered as good, what output is considered as bad. And then after we have a good performance metric, we can optimize against that metric.
Awesome. I like how you guys start with helping clients understand like what to optimize for. It is almost like decide where you're aiming at before you shoot. That definitely sounds crucial. My next question for you is regarding how you guys choose the set of models that you guys dynamically route client requests to. So I know you guys work with a curated set of several hundred models, including both open source and closed. So I'm curious, given the vast number of options out there, like the 500K number we mentioned earlier, how did you guys come up with that curated set? And also, as models evolve and as new ones come out, what is your process for updating your set?
First of all, among the 500,000 models on Hugging Face, most of them are quite irrelevant. They're like tiny models, like non-transformer based, or old models like BERT, fine-tuned versions of BERT. They're not really relevant, but still, there's at least a few hundred relevant LLMs, like different fine-tuned versions of Llama that's used. And that's honestly a big challenge. How exactly do we select them? I don't think there's like magic trick and we can just automatically find the best model. It's more experience-based. You need to live in the AI world to get to know some of the latest models. We have many connections at all those AI providers and LLM companies, and they can provide us with the latest. When we have the initial list, we have a more quantitative method to evaluate different models. So actually, we recently released what we call a provider dashboard. So when you go to leaderboard.withmartian.com, you can see that we basically build an evaluation metric for different LLM providers. So those are not OpenAI or Anthropic. We are more targeting at different model hosting service for open source models like Replicate, Fireworks, Anyscale, or Lepton AI, right? So they host open source models and we evaluate them based on cost, rate limit, throughput, and other metrics people care about. So that's one example we open source to the public. We also have a number of internal benchmarks we constantly run against different large language models. So we have a high level sense what model is good at what and what's their cost, what's their performance. So whenever a new model comes, we have a like pretty good quantitative understanding into that. And then we integrate those models into our gateway. And then for a specific client, it's like a more customized process. We need to run more specific benchmark to that task, analyze their throughput, cost, trade-off, and all things like that. There's no general equation that can apply to any use case.
It sounds like it's a very involved task. No, it takes a lot to figure out the best practice. And once somebody like you guys does, it really doesn't make sense economically for like all development teams to reinvent the wheel.
I actually have a follow-up question, mainly from Jason. Yeah, first of all, like great work, and how do you think there is a main quest in this routing and this evaluation? Like, do you think everything is gonna evolve towards one direction, or is actually still too early to tell? Like OpenAI, for example, I think the main quest is AGI, and the way to achieve AGI is shortest program. That is a scaling law, right? Basically, once you can find the shortest program to represent a data that is most generable, so when they find transformers and when they look at a sentiment, they immediately realize, okay, this will help me find the shortest program, and then they use the language to basically find the most generalizable way with the largest amount of labeled data to achieve that. So that. I feel like that is the technical insight, and it doesn't change.
I think if that's what you're talking about, our main goal, like our end mission, is to make using intelligence as easy as using electricity. We want to commoditize intelligence. So what does that mean? A commodity is something it's interchangeable, like water, electricity, coal, oil. They're very standardized. The different providers, it doesn't really matter. And it's very easy for you to access those commodities because they have a very standardized interface. Right now, LLM is not commoditized. There are many different nuance, all the complexities of using the intelligence provided by LLM. We want to make using LLM as easy as using electricity. So that's our ultimate goal. There are many different ways we can do that. I think routing is a means to the end goal. Routing is not the goal itself. Like routing, I think, is a very important way for model selection to optimize the whole pipeline. But there are so many other things we can do. We can add like new LLMs that do different modification to the LLM. We can do all the things in the prompting layer, and also the model interpretability research we're doing also give us insights into the model itself, which help us understand how to build better LLM pipelines. Our goal is to create a world in which you don't need to, dig into how to use LLM, how to optimize the whole pipeline for half a year, and then you have a product. It should be very, very simple and very straightforward.
Intelligence as a commodity. So
exactly.
This also reminds me about Rockefeller. He owns oil, a refinery, but also railways and pipelines. So like he is the largest resource provider, but he also builds the infrastructure. He is the monopoly of the infrastructure.
Yeah, honestly, I think it's a fascinating topic. Like in the whole LLM industry, we are already seeing different layers, right? There are chip providers, there are LLM trainer, there are inference providers, there are middleware service like routing, and their end products. Fascinating to think about who will take the most amount of revenue. I think there is a very high chance that people like OpenAI can have a big chunk, but it's not 100% the case. If there's like a million models, like I think OpenAI is always going to have the state-of-the-art model, but via routing, we are actually driving a lot of traffic to smaller but cheaper models, which in many use cases might be more useful than the SOTA models. So basically, our interface allows people to access to all kinds of models. So it's possible that this middleware can accrue a lot of value. I think one good analogy is like Google, right? Google basically is a marketplace between a very decentralized like internet of websites and everyone who wants access all those websites. And Google is building the routing layer to connect the two. And Google itself, by utilizing this bilateral network effect, it's able to accrue a lot of value. So I think there's one possibility that the middleware layer can also accrue a lot of value.
The study of this is industrial organizations. Basically, look at the whole supply chain and who has more monopoly power.
Yeah, I was also discussing with some other friends about how the industry will look like. Another very interesting trend is vertical integration. Like OpenAI, they're going to build their own chip. There's people like Grok who build chips that are even more specialized than GPUs, tailored for LLM inference. We also have this tension between verticalized solutions versus each layer like is more horizontal. Like I think one analogy in the past industry is like Apple, they do everything from software to hardware. On the other hand, Intel, they provide a commoditized like standardized chip to every hardware builder. It's uncertain how the LLM industry will look like, but it's a very interesting topic to discuss.
I agree. I recently wrote a blog post on crucial questions on the future of the AI stack, from hardware to infrastructure to applications. It was inspired by a recent blog post from Elex, and so I'll include that link in the show note as well. But this is a perfect segue into our final two questions, which are more broadly about how, where the AI industry is heading. One trend we are seeing is moving towards compound AI systems as opposed to a singular focus on the model itself. So understanding, while it's very important to prompt and fine-tune and retrain specific LLMs to try to push the frontier capability, AI developers are also increasingly using a carefully composed system of not just LLMs, but also other tools to achieve the best end goal. And for example, Google's AlphaCode use multiple calls to LLMs to generate a large sample of code and then to choose the best one from them. Model routing is also a type of compound AI system in the sense that you try to give your client access to a dynamic set of different LLM models to accomplish the task in the optimal way. So my question for you guys is, why is this trend catching on? And why are compound AI systems often preferred, or in some cases even necessary? Let's start with Yizheng.
I think it's a temporary phase. Like LLMs are the first generation, right? It's still new. For example, if I want to do certain things, GUI and existing machine learning models is a possible way, most accurate, reliable, predictable way to do it. And LLM just developed for a year. Right now, GUI and existing machine learning models are at their peak level, right? LLM is at worst of its history. It's only going to get better here and relatively, catch up. I have this analogy of ocean and mountains. I think the current ML models or functions is like mountains. Some are higher and bigger. But large language models, because they are general, they can do many different things. they're like ocean. And when the ocean rises, eventually the mountains are going to become islands, and eventually, it's all going to be water. So I think we'll see increasingly amount of complex tasks being handled by large language models only. The compound model, yeah, of course, it makes sense right now. And I think it's going to have more applications in the next few years, because with the increasing capacity of large language models, it can do more. But I think eventually it will make more sense to just use large language models to handle things in general.
That is a fascinating debate. These other tools and approaches, are they crutches to, nascent LLMs before they become really universally powerful? Or could they be fixtures to stay? Or maybe could they be around for a long time? I guess, how long would that be? So very fascinating question. And Jason, what's your take on this?
Yeah, I love this discussion, and I would respectfully disagree with you, Zheng. I think the compound AI system thesis is gonna last, and I think a larger percent of the value of the whole industry will accrue to the layer on top of LLMs. So some clarification there. So compound AI system actually come from a recent blog post from the founders of Databricks and a few professors at Berkeley. So they basically argue that, and this is what we're already seeing, the best results of single LLM are, without exception, from building all kinds of stuff on top of raw LLM APIs, whether it's simple stuff like chain of thought prompting or few shot prompting, or more complex stuff like alpha code, alpha geometry. They can what we call a neural symbolic system, where you connect LLM to a more symbolic traditional inference machine, and the interplay between them can often yield better results that's better than any single one of them. So I think one analogy that I would like to think of LLM is as a genius human being. Let's say, one of the Martians, like von Neumann. Von Neumann is incredibly smart, but if I want to hire von Neumann to work at Martian, I need to train this person for at least half a year. He's a genius, but he does not have the specific context of the modern age AI. He does not know how to code in Python. He does not know how to collaborate with each of us. So I would think, OpenAI, they are producing genius humans in a commoditized way. Like everyone has access to von Neumann, but that person does not have the specific knowledge, specific context in each of the use case. And the compound AI system building on top of LLMs is basically building the structure of giving the von Neumann all the knowledge, all the context, all the incentive structure necessary for him to perform well in a modern day company. So I think when von Neumann are becoming more and more commoditized, more cheaper and cheaper, the complement of that product is also going to be more and more important. Also from a more selfish point of view, I think we should strive for a world in which all the layers on top of raw LLMs are more important, because otherwise OpenAI just is going to literally take off 90% of the world's GDP. And we're literally going to live in a dystopia controlled by some tech giant. I don't want that to happen. But if, let's say, 50% of the profit accrue to compound AI system, where they build, more specialized version of von Neumann tailored for each use case, the profit sharing will be more decentralized, and the world will be a more open and equitable space.
This is such a fascinating question. Whether OpenAI or whoever is the first to achieve AGI is going to eat the world for better or for worse, or are we going to see 1,000 flowers bloom, not just in terms of different models to choose from, but maybe in terms of the different components in the compound AI system? Maybe 5 to 10 years down the road, we'll see, which way we're heading. And maybe it's a path that none of us are thinking about today. My final question for you guys, since we already were talking about the future of the AI stack, what do you guys think the future of the stack is going to look like? Do you think specific LLMs, or maybe most of the LLMs, might be abstracted away by intermediaries, maybe model routers, or maybe it's some other form of unified interface for LLMs? What is your prediction on this? Let's start with Jason this time.
This is also a question that I'm like constantly thinking about. Is there some similarities between LLM companies like OpenAI and Anthropic to chip producers? Right? So if they're producing a kind of product more standardized and very general, like can do any kind of computing, and there are also companies building on top of that. Well, I do believe that OpenAI and Anthropic, those companies will probably be bigger than Intel. I'm not sure if NVIDIA. I think exactly the dynamic in the industry, whether it's a foundational model, compound AI systems, or specific applications, which part will accrue the most value depending on the economy of scale at each of the segments. We have already seen that LLM has incredible economy of scale, and you invested 100 billion into a model, it can actually be way better. But I think one caveat in that is the scaling lot scales logarithmically. So when you put 1 more billion on top of the 100 billion, the model performance improvement is not as big for the first billion. This is what we are seeing right now. And if that's true in the long term, then it will be easier for other folks to catch up with OpenAI. On the other hand, for the application layer and the middleware layer, I think the economy of scale is a bit uncertain. For example, just like Google, right? If we are able to use customer data, or when we have more clients, more data flowing through our system, our router can become better and better, then our economy of scale will be huge, and we can potentially be even bigger than OpenAI, just like how Google is bigger than any individual websites. But I don't think this economy of scale is as strong as the Google, right? So we will see how exactly does it turn out, and it depends on the structure of the industry.
Yujun, what do you think?
So I want to challenge Jason a little bit. I love the discussion here. Router is a way to make large language models a commodity. But from the end user perspective, they also need to choose between different routers, right? They won't trust one single router.
Yes. I think at least right now, we are building more specific version of the router. It's not like a standardized product like Google where everyone uses the same Google, right? But ultimately, this is the direction we want to strive to. Yeah.
I actually have this discussion with Howie. Like when Howie 20 years ago first seen Google, his first reaction, surprisingly, was another search engine. The last thing we need is another search engine because there were already so many search engines on the market. Nobody anticipated that Google will be any different. So today, I think similarly, whether Martian is going to be, the next Google or not, it's not because Martian is a router. It's because Martian did something very special, like fulfill certain user that people love, and it can constantly grow. To that extent, I don't think the answer lies in is large language model gonna dominate everything, or is gonna be the mid layer, or just one super app gonna dominate everything. I think it still depends on the practitioners who are in the industry to actually create something people like, people find use and grow. Yeah.
Totally. Yeah, I think one anecdote to add on Eugen's point is that, I once read an article saying that, how Jeff Dean and early Google engineers, when they were doing a big deal, there's some bug in the Google system, and they debug, and then they debug to the very chip level. They found out there's some supernova explosion, and that caused, some flow point calculation error in the chips, and then caused Google search results to be wrong. I think this is a great example of how Google is special, why all other search engines fail, because the sheer density of talent and the fact that they are able to do this kind of, detail-oriented, hardcore engineering, it's the reason of Google's success. In addition to the huge economy of scale on Google's business model.
Wonderful observations. And just for audience benefit, the Howie that Eugen mentioned earlier refers to Howie Xu, who is Senior Vice President of AI and Machine Learning at Palo Alto Networks, a industry-leading cybersecurity company. Howie is also an active thought leader and educator on AI. Both Eugen and I have covered his insights before. I love what both of you shared. I can see there's like a super healthy range of opinions here, which I love. I think one fascinating thing about this industry is it's unclear who are going to win out with like the biggest accumulation of value at the end of the day. I think a year and a half ago when ChatGPT first came out, maybe the predominant view was it's definitely going to be OpenAI. But over the past year and a half, we've seen a more like diversification in that opinion. So it has become to some extent harder to tell where the majority of the value is going to accrue or what the future of the industry would look like. This is fantastic. Thank you both so much. And hopefully our audience have learned a lot about model interpretability, evaluation, choosing the right model, routers, and more broadly about the AI industry and its future today. And Yujun, Jason, thank you both so much for being on.
Thank you so much, Sophie.
Thank you.
Dear listeners, I hope you have enjoyed today's discussion. Don't forget to subscribe to this podcast wherever you listen, as well as my free Substack newsletter with the link in show notes. On Substack, I will be posting not just future podcasts, but also deep dive articles and a bunch more content on startups and AI. If you enjoy this episode, please give it a 5-star rating and share it. It would go a long way towards helping others find our channel. If you'd like to get in touch with me or either of my guests today, you can find our contact information below in the show notes as well. See you next time.